Welcome back to the channel. Um, in this section, let's break down one of the most foundational question in any Selenium interview. What is Selenium and what are its components? Let's be honest, okay? Most people answer this question in one line. Selenium is a tool used for web automation. But in an interview, that answer scores nothing. So here is how you answer it like a pro, with depth, clarity, and practical understanding. So, what exactly is Selenium? Selenium is an open source automation framework designed specifically for automating web browsers. It doesn't automate mobile apps, it doesn't automate desktop apps, it only works on web applications. Think of Selenium as a bridge between your code and the browser. When you write automation code, Selenium interprets your commands and performs real actions inside a browser, just like a human user. Open a website, click a button, enter a password. Selenium can do all that. Now let's talk about the Selenium suite, the components. Selenium is actually not a single tool. It's a suite of three main tools. First one, Selenium WebDriver. This is what 98% of companies use. WebDriver allows you to write actual automation scripts in languages like Java, Python, C Sharp, JavaScript, Ruby. It interacts directly with the browser's automation engine. Example, if you write driver.get some URL, WebDriver opens Google in an actual Chrome browser. If you write driver.findelement.click, WebDriver actually moves the mouse and clicks. This is the backbone of modern test automation. Second is Selenium IDE, record and playback tool. Think of Selenium IDE as learning wheels of automation. It's a browser extension for Chrome and Firefox. It allows you to record your web actions, play them back as automated test steps. But you can't build scalable frameworks. You can't handle complex scenarios. You can't properly integrate CI and CD. It's not suitable for professional automation teams. Still, it's useful when you want a demo, you want to quickly generate a basic script, you want to teach someone very new to automation. Third one is Selenium Grid, parallel and distributed testings. Imagine you want to run your test suites on Chrome on your laptop, Firefox on a remote machine, Edge on a different operating system, and Safari running on a Mac in the cloud. Selenium Grid makes this possible. You can run multiple tests at the same time across different browsers, different OS, different machines, real or virtual environment. It saves enormous test execution time. Instead of your suit running for 2 hours, you can finish it in 20 minutes. Real world example scenarios. Let's say your team is working on an e-commerce website. Before every release, you want to test login, add to cart, checkout, payment, profile update. Here is how the Selenium components help. WebDriver automates these tests using real code. IDE help you create quick sample scripts. Grid run all tests in parallel across all browsers. This is how a real automation team works. How to conclude in an interview? Here is a strong closing line. Selenium is not just a tool, it's a complex suite that includes WebDriver for automation, IDE for recording, and Grid for parallel execution. Together, these components give you a powerful platform for building scalable web automation framework. Difference between Selenium WebDriver and Selenium IDE. All right, moving on to the one of the simplest sounding, most commonly misunderstood interview question: what is difference between Selenium WebDriver and Selenium IDE? Let's break this down in let's break this down in a clear, structured, and interview ready way. What is Selenium IDE? Selenium IDE is a browser plugin available for Chrome and Firefox. Its main use is recording actions, replaying actions, generating simple scripts. It works like you click, record, you perform actions like clicking buttons or typing text, and IDE captures everything. What is Selenium WebDriver? Selenium WebDriver is a programming based automation tool. You write code in Java, Python, C Sharp, or any other languages. It interacts directly with the browser using each browser's automation engine. Key differences: skill level. First one is skill level. IDE is beginner friendly. WebDriver is professional level. IDE requires zero coding. WebDriver demands programming knowledge. Second is use cases. IDE, quick test, demos, learning. Okay, it is used only for that. WebDriver, it is used for real automation projects. Third is complexity handling. If the test involves dynamic elements, iframe, pop-ups, conditional logic, data-driven testing, page object model, parallel execution, only WebDriver can handle all this. IDE simply cannot. Framework support. IDE, there is no support. WebDriver supports TestNG, JUnit, CI/CD, reporting frameworks. Fifth one is maintainability. IDE is poor in maintainability. WebDriver is enterprise ready. Some real life examples. Imagine you are working on a login test. In IDE, it's like recording a video. It just captures clicks and typing. But if the login button ID changes, ID breaks immediately. In the WebDriver, you would write a smart locator, add weights, and handle exceptions. Your script becomes stable and production ready. Here is a clear closing line. Selenium IDE is more like a teaching tool used for recording tests, while Selenium WebDriver is the real automation engine that supports coding frameworks and CI/CD pipeline and complex test scenarios. Okay, types of weights in Selenium. This is a concept every tester must understand clearly. Timing issues are one of the most common causes of test failures. Why weights are needed? Web application today use Ajax, JS framework, dynamic content loading. Elements do not appear instantly. If Selenium tries to click too early, the test fails. So we have three types of weights: implicit weight, global weight. Implicit weight, it's a global weight applied once, it waits for all elements. If you just an example, if you set implicit wait for 10 seconds, Selenium will try for 10 seconds before throwing no such element exceptions. But implicit wait is not smart. It does not wait for specific conditions. Now, explicit wait. This is the most important type. It waits for specific conditions like element to be clickable, visibility of element, presence of element, text to be present, alerts is present. So explicit waits are very powerful. Example scenario: a button becomes enabled only after entering password. Use explicit wait to wait for the button to be clickable. The third one is fluent wait. Fluent wait is a form of explicit wait but with custom polling and exception ignoring. One example: wait for 20 seconds, check every 20 seconds, ignore no such element exceptions. So real time scenario would be that imagine an e-commerce checkout page, you click place order and the confirmation message loads after 5 seconds. Without explicit wait, the test fails. With explicit wait, it waits until the message appears. So A good automation engineer always uses a combination of implicit and explicit weight. I prefer explicit weights because they provide fine control and help me avoid flaky tests. Cross-browser testing. Cross-browser testing ensures your web application works the same across all major browsers. Why cross-browser testing is needed? Different browsers interpret HTML, CSS, and JavaScript slightly differently. Chrome may render a drop-down perfectly. Firefox may handle scrolling differently. Edge may have different default settings. Safari behaves completely differently on Mac. To catch these issues, we test on multiple browsers. How to perform cross-browser testing? Local setup using different web drivers executables. You create tests like Chrome driver, Firefox driver, Edge driver, and pass through types like testng parameters, Maven command line, config files. Selenium Grid for distributed testing. You run the same test across multiple browsers in parallel. Grid contains hub and nodes. Hub sends tests to nodes based on a requested browser. Cloud platforms. Tools like Browser Stack, Lambda Test, Source Lab give access to real devices, real browsers, multiple OS combinations. This eliminates the need to maintain machines yourself. Example scenario. Say you have a login test. Run it on Chrome, Windows, Firefox, Windows, Edge, Windows, Safari, macOS, Chrome on Android, and Safari on iPhone via cloud. One script, multiple environments. Best practices: use WebDriver Manager for driver setup. Keep browser setup logic separate. Use factory patterns to create driver instances. Pass browser name through command line or CI pipeline. A good automation suite supports cross-browser testing through WebDriver, Selenium Grid, and cloud platforms. This helps ensure consistent user experience across different browsers and devices. Handling dynamic web elements. This is one of the most important Selenium interview questions because dynamic elements appear everywhere in real projects. What are dynamic elements? Dynamic elements are elements whose ID, name, class, position changes every time the page loads. For example, a button whose ID is button 123, button 987, button 456. This breaks normal locators. How to handle them? Use relative XPath. Instead of matching exact IDs, match stable patterns. Example, locate a button by its text. So we write the code like button text function equal to login, but or by partial attributes like input contains ID user. Use CSS selectors. CSS selectors are fast and short. Use parent-child relationship. If the element itself is unstable, find a stable parent. Use explicit weights. Dynamic elements often load late. Use element to be clickable, visibility of element located, presence of element located. Use JavaScript executor. When elements are hidden or overlaid, we need to use JavaScript executor. Relocate the element to avoid stale element reference exception. Dynamic pages refresh DOMs. Always relocate before interacting. Real example, imagine a flight booking page, seat number, price number, filters, everything loads dynamically. So instead of writing driver.find element by ID seat number or particular seat number, you use driver.find element by XPath, okay, or driver.find element by CSS selector. So we can go for button and look for class, you know, all the classes chapters book. So conclusion is, to handle dynamic elements, I prefer using relative XPath, CSS selectors, parent-child structure, explicit weight and stable patterns like contains, start with, and text. I also relocate elements when dealing with dynamic DOM updates. Okay, so that's all for this video. Thank you for watching. Okay, so hit like and subscribe and drop some comments for improvements. Okay, I'll keep on bringing some nice content and I'll keep on improving it. Thank you. Bye.